In the last video, we took a look at calculating differences between consecutive terms. In this video, we're going to take a look at computing ratios between consecutive terms to determine if a sequence is increasing or decreasing. This is our third and final approach that we'll take. Now, we'll have to go back up to the sequences that we listed up above in our very first video for this section to kind of get an idea of how ratios are going to work and how they're going to be helpful. So let's take a look here at what we did with a sub n in the last video and see how we can make an adjustment. What if I didn't want to do a subtraction between these two terms, but I wanted to do a division? What if I did my n plus 1th term on the top, like a 3, and I divided by a 2 that was on the bottom? Well, 3 over 2 is 1.5. Notice that 5 over 4, that would be another pair I could use, is, 5/4, 1.25. Notice though, if the numbers that are further down the list are always bigger, then when I do a bigger number divided by a smaller number, shouldn't I always get something bigger than 1? If the sequence is regular increasing, where I might have a duplicate, then I might possibly get that this could be greater than or equal to 1. And I could see that the inequality would reverse if I had something with c sub n, or like c sub n or d sub n, where I had maybe 3 over 5 or 1 over 3. Now this approach has some slight complications to it. You can see that sequences that maybe contain a 0 are going to be very, very iffy sequences to use here because I can't divide by 0. So this technique, although very powerful, is going to be fairly limited because I can't use this on any sequence that contains a 0, and I actually have to be really careful with sequences that contain negatives. Notice here, this sequence is definitely going down over time. However, when I take the division of two of these terms, like -8 over -1, I get +8, which might lead me to think that this is increasing. However, that's not the case. So, it's very important to note that I should only use this approach of ratios between consecutive terms if my sequence has all positive terms or all negative terms. I don't really want to do it if there's a mixture, and I need to have no 0 terms. I need to make sure that I meet those restrictions or this approach isn't going to work well. So let's see if I can make that or check those conditions here. Well, I'm working with n over n plus 1. Clearly everything out of that list is going to be positive and never going to be 0 if n starts at 1. So we should be good to go. So we're going to go ahead and calculate a sub n plus 1 over a sub n. Much like what we saw in the last video, this is going to be n plus 1 over n plus 1 plus 1. That's my a sub n plus 1 over my regular old a sub n. Of course, since I'm dividing two fractions, I can simply just multiply by the reciprocal, which would be n plus 1 over n. Now if I go ahead and I multiply this out, notice I'm going to get n squared plus 2n plus 1, and in the denominator, I'm going to get n squared plus 2n. Well, if I look at that fraction, my goal again is to figure out, is this bigger than 1 or smaller than 1? And it seems like here, well, isn't the top definitely going to be bigger? Every time, no matter what I pick for n, the top is always 1 more. So this should always be bigger than the value of 1, guaranteed. And this works here for all values of n greater than or equal to 1. So if a sub n plus 1 over a sub n was greater than 1, that implies that a sub n plus 1 is greater than a sub n for all n greater than or equal to 1. These are the three ways that I can determine if a sequence is increasing or decreasing. We're going to be using these techniques a lot throughout Chapter 5. So again, it's really important that you understand how we utilize these techniques. It might even be advantageous right now to pause watching these videos and to go take a look at the worksheet associated with the section, begin to play around a little bit with some of the questions there, See if you can determine when using one of these approaches is going to be good, when it might not be so good. Maybe try multiple approaches on the same sort of question, like we did here. In the next video, we're going to introduce a new piece of terminology and start to see how we can summarize a lot of these ideas here and find their usefulness in terms of calculating limits of sequences.